Hello, welcome to the first lecture on measures of location. Our learning outcome is to calculate the mean, median and mode for a data set. In this lecturette, we will consider ungrouped data. The most common measure of location is called the mean, and it is often just called the average. The formula for the mean, x bar, is x bar equals the sum of x divided by n, or the sum of f of x divided by the sum of f, where x is a data value, f is the frequency of each x, in other words the number of times it occurs, and n is the total number of data values. This symbol sigma, this means to find the sum of. So in other words, to add up all of the values of x, or add up all of the values of f of x, or add up all of the values of f. Let's look at an example. Find the mean of the following list of data. And we have a selection of numbers, discrete numbers. Remember the formula for the mean, x bar equals the sum of x divided by n. And so here we add up all of the values of x. Here they are. And it's 47. Now we have 10 numbers altogether, so n is 10. So using our formula, we simply do the sum of x 47 divided by n 10 equals 4.7. Therefore the mean is 4.7. Now let's do an example using a frequency table. A scientist counts the number of eggs in some song thrush nests. So in case there's any confusion, this is a nest of eggs and this is a song thrush. And here is the data that the scientist collected. And we want to calculate the mean number of eggs in these nests. Remember the formula for x bar, the mean, and this time we're going to use this formula because we have a frequency table. So this means we need some more rows to our table and a column. We need a row to show the values of f of times x, and a column to show the totals of the sum of f and the sum of f of x. Let's do that. And here we have it. Here is our row showing f of x and our column showing the sum of f and the sum of f of x. Now we simply apply our formula, substitute our numbers, sum of f of x, 157, and the sum of f is 40. Using a calculator, we get 3.925. So the mean number of nests, the mean number of eggs in nests is 3.925. Now let's look at two data sets. We can find the mean of one data set. So here is the first data set, x1. And we simply apply our formula, do the sum of x divided by n, which is 5. 20 divided by 5 is 4. So the mean of x1 is 4. Then we have a second data set called x2. And again, we apply our formula, the sum of x divided by n, this time n is 3. 36 divided by 3 is 12. Now if we wish to find the mean of the combined data set, we can do it manually, putting all of the numbers together. So this is both sets of numbers here. And we can do exactly the same, add them all up and divide by the number we have, and we get 56 divided by 8 is 7. So the mean of the combined data set is 7. But what do we notice? Well, actually what we notice is that if we look at the number 56, we see that that is actually the 20 plus the 30. And if we look at the number 8, we see that that is the 3 plus the 5. How do we write that with an equation? Then here it is. And we have used n1 and x1 for our first data set, n2 and x2 for our second data set. And we have the formula: the mean of the combined data set of x1 and x2 is n1 times x1 bar plus n2 times x2 bar divided by n1 plus n2. So let's look at another example. Here we have an example where we don't have the raw data, but we do have mean values and the number of values in each data set. So a data set consisting of 5 values has mean x bar 1 of 4. A second data set consisting of 3 values has mean x bar 2 of 12. Find the mean of the combined data set. So here we have n1 equals 5 from there, n2 equals 3 from there, and using our formula we know that x1 bar was 4 and x2 bar was 12. So substituting into our formula, we get to the same answer as before. 56 divided by 8 equals 7. Let's look at the mode now. The mode is the most frequently occurring data value. Now, sometimes there is no mode at all if each data value only occurs once. Or, if every data value occurs the most frequently is a mode, then there can be more than one mode. Let's look at an example. Find the modes of the following data sets. So in the first data set, we look for the number that occurs the most often, and actually we can see that it is the value 2, so the mode is 2. In the second example, we actually have 2 modes because the number of 4 appears twice, but also the number 5 appears twice. So we have 2 modes, 4 and 5. Another example. This time each value only occurs once, so that means there are no modes. And in our last example, as we have ordered it, it's easy to see that each number actually appears twice. They all appear the same number of times. So this means that there are 4 modes, 2, 3, 4 and 5. So as you can see, the mode is not always very useful to tell you about your data and where it is centred. So the last measure of location is the median. And the median is the value in the middle of the data set when all of the data values are placed in order of size. So you first put your n data values in order, then we have to find the position of the median in the ordered list. There are 2 possibilities. When we do n divided by 2, we may get a whole number, and that occurs when n is even. And in this case, the median is halfway between the values in this position and the next position above. But if n is not a whole number, in other words n is odd, then the answer we get for n divided by 2, we round it up to the next whole number to find the position of the median. Now that sounds a little complicated, so let's look at an example. Find the medians of the following data sets, and here is the first one. The first job is to put the numbers in order from lowest to highest. There are 9 data values, so we can see that actually in this case n is odd. And n divided by 2 is 9 divided by 2 equals 4.5. So because n is odd, then we will round 4.5 up to the next number, which is 5, and the median will be the 5th value in the ordered list. So if we count, we've got the first value, second value, third, fourth, and 5th. So that tells us that the number 6 is our median. A second example, again, put the numbers in order from smallest to largest. This time, n is 10, so n is even. 10 divided by 2 is 5. Because n is even, the median is halfway between the 5th value and the 6th value. And if we count along, we can see that the 5th value is the number 7 and the 6th value is the number 8. So we need halfway between 7 and 8, which is 7.5. So our median is 7.5. Now let's look at an example using a frequency table. The number of letters received one day in a sample of houses is shown in this table. So we can see from this that 11 houses received no letters, 25 houses received 1 letter. Oops. Let me try that again. 25 houses received 1 letter, 27 houses, oh dear, 27 houses received 2 letters, and so on. And we want to find the modal number of letters. Now the modal number of letters just means the mode. Now if we look at the number of houses, we can see that the highest frequency is 27. So that means that the modal number of letters is actually 2. So our mode is 2. Now say for the same data we wish to find the median number of letters. Now remember, for the median we put our data values in order from lowest to highest, and then we need to find the position of the median according to n, the total number of pieces of data we have. So it would be useful to have a cumulative frequency column, and here it is added onto the end. There. Now looking at the cumulative frequency column, we can see that we have a total of 100 houses, and so we have a n equals 100 here. So to find the median, we need to do n divided by 2. Well, n divided by 2 is 50, so where is the 50th number? But n is even. So what that means is, if it's even, then we need between the 50th and the 51st number. So where are they, the 50th and the 51st number? Well, looking at our cumulative frequency, we can see that from the beginning